We're outside a distributing station. They have receiving stations and distributing stations here in Los Angeles. Basically what happens is they generate the power, and a lot of the power that we have here we generate in such places as like Hansen Dam. They use the movement of the water to do turbines and generators, which go ahead and turn the movement into electricity. Then what they do is they transform, or they transport that on wires at 500,000 volts across the desert. See those big towers over there? The high wire, those are high voltage over there. And then it goes into a station where you can see all of these electricity is flowing. Those things that look kind of like they're brown or gray and they look like a bunch of little saucers put together, those are insulators. What they do is the framework is made out of metal, and they don't want the electricity to jump a few inches or jump 6 or 7 inches. So you see those things are 12 inches long. Those are insulators to keep the electricity away from the grounded metal. But this is basically a receiving station or distributing station for water and power. We're going to take another example of an overhead service feed. Notice over at this house, the lower two black lines are probably telephone and cable TV. But the one that has the gray pipe sticking out, that is your 120/240 feed from the telephone pole. Look at the pole there with all the wires. On the lower part of a telephone pole, you'll have cable TV, you'll have telephone, and then the higher you go, you have higher voltage. Once again, we can see how an overhead feeds is not as aesthetically pleasing. And also sometimes if you have high trucks, or depending upon where you're walking, the overhead feed can become entangled with whatever you're doing. Notice here the overhead feed is much lower and it's feeding that house across the street. Here we're going to do a little bit more of a close-up of an overhead service feed. You cannot see the rigid pipe going inside the stucco. It's about 1 inch behind the stucco. But you can see where the drop is, the service drop. That's what they call the service drop for the home. It goes into the wall, and then it goes in that panel. It has a little bubbly meter on the outside. Another service feed would be right here. You can see there's a gray wire. It's a spiraled wire. It's 3 wires. One is the neutral cable, and the other 2 gray insulated wires wrapped around the triplex. And that's a service feed on top of that roof there. In this neighborhood here, you don't see your electrical overhead feed in the front as much as you do in the back. Let's take a look. If you can see that pole there, with all those wires, that's the feed for the back. If you're curious what other types of things are in your streets, or how feeds go into homes, here we see a G. This means the gas line is there and it feeds to the side of the house. If you're curious why we didn't see overhead wires in this neighborhood, it's because they're in the back, okay? You can see when you look out, you have the higher voltage on top, and then you have 2 wires going to your canister, or to your transformer, your gray can, and then it's going ahead and dropping the voltage down to your 120/240 in the lower level. So now we're going to do a close-up of your electrical panel. If we look above us, this is a newer panel, so it's what you call a surface mount. This panel is not in the wall, this panel is on the exterior. It was in the back of the house, but it was relocated. In Los Angeles, Water and Power tells you where your new meter can be. Even if you have one on the outside, they may say, nope, can't be there. Wherever you put a meter, they have to okay it. It's called calling them and asking them to spot your meter. This meter has your, it has the meter that charges how much power I'm using. It figures out how much power I'm using, and they bill me accordingly. And then I have my breakers down here. Basically, your electrical panels are either on the side of the house, front of the house, or back of the house. The water and power company or your utility company typically wants them somewhere in the front so they don't have to invade on your privacy to find the electrical panels. Older homes, it's in the back. This is your gas meter going to the house. This is an anti-earthquake valve. If you hit it, it will turn off the gas to the feed to the house. I see an opportunity, I'm going to take it. Here we have an air conditioning unit. When you have an air conditioning unit, you have to have a disconnect. It's over here on the side. This is your disconnecting means. It's all weatherproof. You have your flex connector with your hot wires and ground wires. And if we look more closely, we have a nameplate. Can you see the nameplate? We're in the back of a house. Notice the lower wires. Those are your cable, TV, and telephone wires. As you go up, you see your 3 wires, which are your house voltage wires. And then as you go way up, you see the transformer can and the 2 wires that are your higher voltage yet. Once again, we have our higher voltage over there, and then at the lower part of the can, it goes to 3 wires. That's your 120, 240. And then they take it on the side of the house. Let's take a look over here on the side of the house. It goes to another pole. In this particular case, you have several houses that this lower voltage feeds. Now we're going to do a close-up of your service drop. The utility companies will typically, they're in charge of all the wires up into the service drop. The service drop feeds your electrical meter, which they gauge on how much electricity you use. And then it goes into your service panel, which has a whole bunch of breakers and feeds different applications in your house. Here's your service drop. Notice there's 3 wires. The neutral wire is also connected to the ground of the mast. And then with the big round black things, those are your 2 hots. So each hot is 120 volts. Your lower wires here have to do with your cable, TV, and your internet. These are cable. These are okay to touch.